Good morning once again and welcome to the second session of the UKZN Metric Intervention Program for Mathematics Paper 1. We are going to continue with the Paper 1 and focus on the questions that we did not do in the first session. But just to have our questions following each other in sequence, I am going to go through quickly what we did in question 1, including the question that we did not do because we said it was a bit difficult. We are, however, going to do that again. Now that will be followed by question 2, question 3, in that order. Now we did question 4 and question 5, but we're going to focus on those sub-questions that we couldn't do. That will be followed by question 6. We did question 7. We did question 8, but we did not finish. So question 8 will be done, and question 9. The only question that we're going to leave out for today is question 10 and question 11. Those are the last two questions whose weight is slightly less than 15 marks. Okay, so as I've said before, that our focus will be on the questions that carries a bigger weight. So we have started with such questions. It was question 1, algebra and equations. Question 4 and 5, functions and graphs. Question 7, question 8, question 9, which is calculus. Now, we will then continue with the rest of the questions. Right, that is what we did in question 1, factorizing our quadratic equation and then solving for x. The next question, 1.1.2, which is a quadratic equation that cannot be easily factorized. Hence, we were required to use the quadratic formula. Now, that is the inequality which we solved by applying the graphical method. Now, we discussed this again last time, so I'm not going to go through it. Solve for x in this set. We did that question. And then the simultaneous equation, whose solutions we obtained last time, and the ordered pairs, by the look of things, were just 1:11 and 14:-2. Okay, again, this question was done. This is the question that I said, let's leave it because we cannot immediately see what exactly must we do about it. So it's time for us to do it now. Here we're required to, or we're considering the product of numbers 1 times 2 times 3 times 4 up to 30, and we are required to determine the largest value of k such that 3 to the power k is a factor of this. Now, I would like us to do the analysis. Now, we are going to look at the factors of 3 in this product. The first would be 3, followed by 6, followed by 9, followed by 12, 15, 18, 21, 24, 27, and then 30. Again, we can reduce this. Here, we are interested in the 3. And there, we have got a 3 because 2 is not divisible by 3. But now here, we actually have a 3 squared. And there, we have only 1 3 because it's 3 times 4. And here, we have got only 1 3. Let me just put a multiplication sign in between. Here, we have got 9 multiplied by 2, which means that we have got a square of 3. And here we have only 1 3 because 21 is 3 multiplied by 7. 24 is 3 multiplied by 8. 27 is 3 times 3 times 3, which is 3 cubed. And 30 is 3 times 10. And we have got only 1 3 there. Now, when we add them up, you will see that here we can say it's 1 plus 2 plus 2, which is 4, plus 1 5, 6, plus 2 8, 9, 10, 13, 14. So that can be written as 3 to the power 14. So we can then claim that our k is equal to 14. Okay, we are done with question 1, 1.3. Now I would like us to move over to question 2. Question 2. Here we are required to write down the next 2 terms of the sequence. Now, what is important for us, we are told that this is a quadratic sequence. Okay, that is important. A quadratic sequence. Now, as it is a quadratic sequence, we must first of all look for the first difference. So we take these numbers as they are: 3, 2, 1, 290, 261, 2, 3, 4. Now we look at the first difference. Now, in this case, 290 minus 321, we're going to get minus 31. Now here we're going to get minus 29, and we're going to get minus 27. So that tells us that if we are to move on, there is a pattern on these numbers. They've got a common difference of 2. So which means that the next difference would be minus 25. That is the number that we're expecting. So that means that the number that should stand here is 209. And if we are to move on with the differences, minus 23, and the next number is 186. So the conclusion is that the 2 terms that we're looking for, 2 required terms, are 209 and 186. Remember again that here we have got our second difference, which is 2, and that is constant. So here, this is our first difference, and that is the second difference in this case, which is constant, and it is 2. Determine the general term. Now there are formula that we shall be using to determine that. Now for the first difference, remember that the first difference is 2, and here we have got minus 31, and there we have got 21. These numbers are important. Let me use another color. It's 321 minus 31 and 2. Now the formula for these three numbers that I have highlighted are as follows. 2a is equal to 2, and then we have 3a plus b, which should be that minus 31, and lastly a plus b plus c is that big number 3 to 1. Now to solve for a here, we get 1, and we substitute a here, the value of a, which means that our b must be minus 34, and then we substitute all these three values. Then we get c equals to 3, 5, 4. So our formula Tn is n squared minus 34n plus 3, 5, 4. Now that is a quadratic formula. If we were required to draw a graph, or we can say it resembles the graph of y equals to x squared minus 3, 4x plus 3, 5, 4. I'm sure that we will use this idea in the following questions. Now, which term of the sequence will have the value 74? So it's a matter of solving. Tn must be 74, which implies that n squared minus 34n plus 3, 5, 4 is 74. Now when we simplify, we get n squared 34n plus 280 equal to 0, and that can be factorized. Now the factors of 280, whose sum will be 34 are 14 and 10. Now the signs, both negative. Therefore, n is 14 or n is equal to 10. Now that is very important. So the terms of the sequence that will have the value of 74 is term number 14, that would be 74, and term number 10 will be 74. In the quadratic sequence, which term of the sequence has a least value? Now, if it was in the previous session, I would say let us leave this question and we come back to the end. But I would like us just to go through this quickly because it is a problem that is doable. You will remember that I said this is a quadratic and it can be associated with y equals to x squared minus 4n plus 354. Sorry, I made a mistake, 354. Now, if we are to draw this graph, note it's x minus 14 into x minus 10. So this graph will look like that, where we have got 10 here and we have got 14. Now, if we talk about the least value, the least value is here, somewhere there. And that value, if you look at it, it is just in between 10 and 14. So by using that, by using this graph, we can say that value is n or x because we are using x. X will be 10 plus 14 divided by 2, which is 7. Or we can say, since it corresponds to the turning point, x is minus b all over 2a, the x value there. And here we have got minus 4 all over 2. I'm sorry, I made a mistake again. That was 14. Okay, minus 14. So that is just 7. We can also use calculus. So that is method 1. Method 1. And that is method 2. And method 3. We can just use calculus and say minimum or maximum is obtained when the derivative is 0. Now the derivative is 2x minus 14, and it must be 0. So when we solve for x, that tells us that x is equal to 7. Now returning to our notation, because we were using n, we can say that therefore the required value of n is 7. Question 2, you are given a geometric series that will require some calculations. That geometric series, and we are required to find the value of k if the series has 21 terms. So the first term is 5/8. I think I need to give myself enough space here. Starting right here, A is 5/8. The common ratio is half, and n is equal to 21. Now the formula, which is the sum to 21 terms, I think I need to write down the general formula first so that we know exactly what is it that we are dealing with. Sn is equals to A into 1 minus r to the power n divided by 1 minus r. So our n is 21 and our A is 5/8. 1 minus a half to the power 21 divided by 1 minus half. Okay, now I am going to use the calculator right away and get 1.2499, which is approximately 1.25. In the next question, we must find the value of n for which Tn is greater than 5/8,192. Now, Tn is given by a r to the power n minus 1, and that must be bigger than 5/8,8192. Now our A is 5/8 and our R is half, and we have got n minus 1 bigger than 5/8,192. Now when we simplify and divide or multiply throughout by 8/5, we get half n minus 1 bigger than 1/1024. So that is a half to the power n minus 1 bigger than. That is the same as 1/2. Now the powers, it's half raised to the power 10. Now we need to change and rewrite this so that the base is a number that is bigger than 1. So this should be 2 to the power minus n plus 1 bigger than 2 to the power minus 10. Okay. I am going to draw a graph now illustrating or explaining the solution. Now the graph of y equals to 2 to the power x. the graph y x. So this is the graph of y equals to 2 to the power x. If we say in this graph that 2 to the power p is greater than 2 to the power q, it implies that p is bigger than q. And the reason is that this graph is a one-to-one and it is increasing. So that is the conclusion that we can immediately draw. So in this case, the fact that we have got our base as 2, we can draw the conclusion that minus n plus 1 is bigger than minus 10, which means that minus n is bigger than minus 11, or n is less than 11. So a number that is less than 11, which is natural because we're dealing with natural numbers here, will just be 10. So we conclude that n is 10. There we go. Now that is the next question, question 3, and we are required to determine the value of that expression. Now the first expression when we substitute 1, that was copied incorrectly. It was supposed to be 3 and 3. Now if we substitute 3, we get 1 over 1. Substitute 4, we get 1 over 2, 1 over 3, 1 over 4, up to the last one is when we substitute 10, which gives 1 all over 8, minus, in the second expression, when we substitute 3, we get 1 over 2, followed by 1 over 3, followed by 1 over 4, 1 over 5, and it carries on and passing, because if y is 9, we get 1 all over 8, and if y is 10, we get 1 all over 9. Now the terms, half up to 1 all over 8 will cancel out, and we will remain with 1 minus 1 all over 9, which is 8 over 9. All right. We have got a pavilion, steel pavilion, at a sports ground, which comprises of a series of 12 steps, of which the first 3 are shown in the diagram, and each step is 5 meters wide. Each step has a rise of 1 over 3 meters and has a thread of 2 over 3 meters. I made a mistake here and I would like to correct it. That is shown in the diagram. The open side of the shaded or the shaded sketch on each side of the pavilion must be covered with sheeting. Now calculate the area in meter squared of the metal sheeting needed to cover both open sides. Now we need to analyze this. Look at it very carefully. We are going to look at the first area, and that is the second area, that is the third. Now when we look at them, we will see, or you will notice, can I quickly look at the picture? Okay, nothing is here, but you will see that for the first one, that one, the area will be 1/3. No, it should be 2/3 times 1. In other words, that is this times that. So the next one here will be 2/3 multiplied by 2/3. The other one, the third one, will be 2/3 multiplied by 3/3. And they follow each other in that sequence. Now let us write them, including those that do not appear on the picture. Just for one side, and the other side is the same as the one that we are dealing with. So we are going to calculate the total area of the side that we are seeing and then multiply that by 2. The area of one side is the first block will be 2/3 multiplied by 1/3, and that is followed by 2/3 multiplied by 2/3, because that would be the height of the second one. Now the next area is 2/3 multiplied by 3/3, followed by 2/3 multiplied by 4/3. And that goes on up until the 12th block, which will be 2/3 multiplied by 12/3. Now we can factorize here and get 2/3 into 1/3, 2/3, 3/3, 4/3, up to 12/3. And that can also be written as 2/3 times 1/3 into 1 plus 2 plus 3 plus 4 up to 12. Now what we note about the sequence in brackets is that it is an arithmetic sequence whose first term that is an arithmetic series. As an arithmetic series, A is 1 and D is 1 and N is 12. So the sum using Sn equals to N all over 2 A plus L. I'm going to use that short formula. In this case, it's S12 equals to 12 all over 2 into 1 plus 12. And that is 6 times 13, which is 78. It looks like I will not have enough space below, but I'm going to do the final calculations. Now the area of the first site, area, I will call it A1. I will call it A1. Will be 2 all over 3 times 1 all over 3 times 78. And that will give us 17.33. So the total area then, total area will be 2 times 17.33, which is 34.67. Okay. Question 4. Well, we did this before, so I'm not going to do it again. The solutions were written or were obtained previously for 4.1. Again, for 4.2, we calculated the values of A and B. 4.3, we calculated the coordinates of C, which was the turning point of the parabola. We wrote down the range of F. We did all these questions. Now that is the only question that we couldn't do in our last session. Now, when we look at the question, we are given a function h of x equals to f of m minus x plus q. And we say it has got only one x-intercept. It has got only one x-intercept, and that occurs at x equal to 0. So that is a quadratic function. So if it occurs at x equal to 0, it tells us that this is how the graph look like. That is the graph of h. It has got only one x-intercept, and that occurs at x equal to 0. Okay. Now, what we shall do first would be to simplify h of x. h of x will be f of m minus x, which means that where there is f of x, or where there is x in f, we put m minus x, plus b, our b was 2, m minus x, minus 3, plus q. Now, the x-intercept, I need to save space again. This function has got an x-intercept at 0. Which means that h at 0 is equal to 0. So 0 is equals to m minus 0 squared plus 2 m minus 0 minus 3 plus q, and when we simplify, we get m squared plus 2m minus 3 plus q. Okay, we can call this our first equation in an attempt to find the values of m and q. Now, at x equal to 0, we see that that is the turning point. If it is the turning point, we need to look at h of x first, and we expand. Now, h of x, before I can apply that idea of the turning point, h of x is m squared minus 2mx plus x squared plus 2m minus 2x minus 3 plus q, and that would be x squared minus 2m plus 2x plus m squared plus 2m minus 3 plus q. Now, for this graph, we know that it has got a turning point at 0. But the x value at the turning point is given by minus b all over 2a. And this x value is minus into minus 2m plus 2 all over 2 times 1. And when we simplify, we are getting m plus 1. We're getting m plus 1. But we know that the x value at the turning point is 0. So that means that this is 0. So we draw the conclusion that m is minus 1. That is our second equation. m equals to minus 1. Now we substitute that in 1. When we substitute in 1, we will get 0 equals to minus 1 squared 2 times minus 1 minus 3 plus q, which means 1 minus 2 minus 3 plus q is 0. And we can conclude that q in this case is 4. We are done with question 4. Question 5 was done in the previous session. We need to look at question 6. All right. Question 6. Two friends, Guda and Tabo, each want to invest 5,000 rand for 4 years. And Guda invests his money in an account that pays simple interest of 8.3% per annum. At the end of 4 years, he will receive a bonus exactly of 4% of the accumulated amount. And Tabo, on the other hand, invests his money in an account that pays interest at 8.1% per annum, compounded monthly. Now we need to compare these investments and tell which one will yield a better return at the end of 4 years. Now for Guda, I'm going to separate the two. Now for Guda, A is P into 1 plus I times N. That is the formula for the amount that will be accumulated in 4 years using the simple interest. And that will be 5,000 into 1 plus the interest is 0.083 and it is accumulating over 4 years. Now we can use our calculator to get 6,600. But at the end, he will get an accumulated bonus. Bonus will be 6,600 multiplied by 4%, which is 4 over 100. Now that will give us 266 rand 40. Now we need to add this amount on the total return. So that means that the final amount that he gets will be a total of these two amounts, which is 6,926 rand 40. Now on the other hand, Tabo for Tabo, his investment is growing at 8.1% compounded monthly. Now the formula is P into 1 plus I to the power n. So A in this case will be the 5,000 into 1 plus 0.81% divided by 12. But this is compounded monthly, which means that for our n, we are going to use 12 multiplied by 4. Okay, the final answer will be 6,905 rand 71. So from here we conclude that Guda will get a better investment. That takes care of 6.1. Okay, I am going to start question 6.2 from the beginning. 9 years ago, a bank granted Mandy a home loan of 525,000. And this loan was to be repaid over 20 years at an interest of 10% per annum, and that was compounded monthly. Now, Mandy's monthly repayment commenced exactly 1 month after the loan was granted. Mandy decided to make a monthly repayment of 6,000 instead of the required 5,066 rand 36 cents. How many payments will she make to settle the loan? Now, this is a repetition of what I did earlier. We shall use the present value formula because presently Mandy has got a home loan of 525,000 and he is currently paying 6,000 rand, and that payment will be done over or for n period of time, which is what we are required to calculate. Now the formula for that is given, and then we are going to substitute all the required values in this formula, which is what we have done here. And then we simplify or we divide on both sides by 6,000, followed by multiplication by 0.1 all over 12. And that is the equation we arrive at, which further simplifies into this equation. And then, because we want to solve for n, we take the logs on both sides, getting into this step. And then after that, we use our calculator to get n equals to 157.4. And n equals to 157.4 can be approximated by 158. So he actually made about 158 payments. That takes care of 6.2.1. Now we get to 6.2.2. After making monthly repayments of 6,000 rand for 9 years, Mandy required money to fund her daughter's university fees. She approached the bank for another loan, Instead, the bank advised Mandy that the extra amount repaid every month could be regarded as an investment, and she could withdraw this full amount to fund her daughter's studies. Now we are required to calculate the maximum amount that Mandy may withdraw for the loan. Now look, our focus is no longer on the full monthly prepayment of 6,000 that Mandy is doing every month. But we are going to focus on that difference because he's paying more than the required amount. Now the difference in this case, the difference is the amount 6,000 minus the required payment. And that gives 933 Rand 64. So we would like to know the future value of this amount after adding the interest. So the future value of this amount well, we can put F is given by the formula X into 1 plus I to the power n minus 1 divided by I. And simplifying this amount or substituting the values 933.64 into 1 plus 0.1 all over 12, and this will be for a period of 9 years. So we multiply we put 9 multiplied by 12 minus 1 divided by 0.1 divided by 12. And the final amount is 162,503 Rand 51 cent. So that is the maximum amount that Mandy may withdraw from the loan account. So in other words, we can say these are the accessible funds. Question 6 is complete. We did question 7 before. So I'm going to check any sub-question that we might have left out, and we do right now. And it seems like we did almost everything on question 7. Now we do question 8. Like before, I have said we're going to do question 8, question 9, and we're going to leave question 10 and question 11 for the next time. So we are going to do question 8 and focus on those questions that we did not do. 8.1 was done. 8.2 was done as well. And I might have not explained 8.2 in details. I think it's time for me to explain that because we have some little time left before the end. After flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. The path that the insect crawled can be described by ht equals to t minus 6 into minus 2t plus 3t minus 6, where h is the height in centimeters above the floor and t is the time in minutes since the insect started crawling. How many times did the insect reach the floor? Well, the answer would be it will reach the floor when ht is equal to 0, which means we're going to solve that cubic equation, which has been nicely factorized for us. Now, the first value that we obtain there is t equals to 6. Now, to get the other values of t, we solve the quadratic equation by using the quadratic formula. Now, what we realize in using the quadratic formula is that the answer that we obtained here was not real, because the square root of negative 39 is not a real number, but it is imaginary. So there is no real solution in this case. And the only real solution is 6. So that tells us that the insect reaches the floor only once at time t equals to 6. 8.3 we did not do last time. I think it was because of time. Determine the maximum height that the insect reached above the floor. Well, we have expanded h of t and we are ready to find the derivative. Now we know that the maximum, let me change the color to blue. The maximum is reached when the derivative is 0, which means minus 6 t squared plus 30 t minus 24 is 0. We can divide by minus 6 on both sides, getting t squared minus 5t plus 4 equal to 0. And the factors are 1 and 4. Well, we can calculate h. We can use both values of t to calculate h. The calculated value when t is 1 is h of 1, which is 1 minus 6 into minus 2 times 1 squared, 3 times 1 minus 6, and that will give us minus 5. That is minus 2 plus 3 is 1, minus 6 is minus 5, and the answer is 25. We can also use 4. H at 4 will be 4 minus 6 into minus 2 times 4 squared, 3 times 4 minus 6, and that will be minus 2 into, now here we will have minus 32 plus 12 minus 6 minus 2 into minus 32 plus 12 is minus 20, minus 6 is minus 26, and that is, no, not 32 but 52. Therefore, the maximum height is 52, because that is the highest, and it is reached when t is equal to 4. Okay, we're left with question 9, and we need to do question 9 quickly. It's not a very long question, but it's not that easy. Now we need to solve. We are given that f of x is 3x cubed. Now we must find f equals to the derivative of f. The derivative of f is 9x squared, which means that f (3) x cubed equals to 9x squared, means x cubed minus 3x squared is equal to 0. Therefore, x squared into x minus 3 is 0, which means that x is 0 or x is equal to 3. So those are the two values of x, such that f is equal to the derivative. Now the graphs of f, derivative of f, all pass through the point 0, 0. Okay. If you look at these graphs, I am going to, just to show you, to explain this problem. F is a cube, is a cubic function, and then the derivative, let me use another color. We can use green. For the derivative, because it is a parabola. So that is f, and that is the derivative. Now the second derivative is simply a straight line. Let me use that color, because note that f of x is 3x cubed. The derivative is 9x squared. Now the second derivative is 18x, and 18x is just a straight line. Now, for which graph is 0, 0 will be a stationary point? That would be a stationary point only for f and also for the derivative, because these are the graphs. F has got a point of inflection, and the derivative has got a turning point. So it's only, let me just write down in full. As the answer, it's f and the derivative of f only. Now explain the difference, if any, in the stationary points referred to in question. I think I have mentioned that, because I have said for f, it will be the point of inflection, and for the derivative, it will simply be the turning point. Okay, now determine the vertical distance between the two graphs at x equal to 1. Okay, now we know what f is. The derivative is given by 9x squared. The second derivative is given by 18x. Now at 1, x equal to 1, the derivative is 9, 1 squared, which is 9, and the second derivative is 18 multiplied by 1, which is 18. So the difference, or the distance, the vertical distance, will be, we start with the bigger number, subtract a small number, we get 18 minus 9, which is 9. Find the values for which the difference between f and its derivative is less than 0. We're going to take that straight away. F of x is 3x cubed minus 9x squared is less than 0, which means 3 x squared into x minus 3 is less than 0. Now the conclusion is, we all know that x squared is always positive. Hence, 3 x squared is always positive. So, a positive multiplied by something will give us a negative. The conclusion will be it's x minus 3. That is negative. So, x is less than 3. And again, the restriction would be that x must not be equal to 0. Okay, I think I should have said here x squared is bigger or equal to 0. Now, if x is 0, then that inequality is not satisfied. So x must not be 0, and x should only be positive. I mean, x squared should only be positive. All right, we are done with all the questions that we wanted to do for the day. And I would like to thank you very much for listening to us, hoping that all the solutions that we did and all the explanation that we have made, and even at those points where we put a strong emphasis, you will take everything into consideration and pass the 2020 end of the year examination. I wish you a good luck in this coming examination. Thank you.